Hey, thanks for having me here today. I'm really excited. And you started seeing this this title up here, and you're like, "Oh, cool! Like BuzzFeed has now written a presentation. That's great." And but in seriousness, this has been a journey for me. This talk, and I've been thinking like, what does it make? What does it mean to be effective at doing DevSecOps? What does that look like? And then in here, a little bit later, I introduce what I think is a framework that we can use that might be helpful for it. So, so here's me. I'm now over at Verica, and I have been in Signal Sciences for the last 5 years, and it's been really great over there. I have some courses on LinkedIn Learning, and I live in Austin, Texas, and I help with several of the conferences down there in Austin. And then I have a request at the end of the whole talk, and it's going to be for help. We're working on the DevSecOps handbook right now with IT Revolution over there with Gene Kim. And I'd love to hear your stories about DevSecOps successes, failures, any of that kind of stuff. So, and I'm actually really good at this. This is, I don't know if you can see the subtitle, but it says paying $1,500 to browse Twitter and hang out on Slack. And so I like the in-depth part too, but I actually specialize in this skill. So if you want to skip straight to the slides and be able to have a copy of them, because I have some links in here, you can go to this bit.ly. If you want to take a picture of it, you can grab that real quick, and I'll have this up at the end as well. But you can get the slides right now. All right. And and one thing on Verica. So the place where I'm going, I actually don't work there just yet, but will here in a couple weeks. But we're an enterprise platform that's a complete startup working on continuous verification, taking a lot of the chaos engineering principles and applying that to see how we can make the world a better place. Okay, so I think we should start out with DevSecOps. And what does that mean? What do we think it means? And I think the best way to get started with that is to look at, do some DevSecOps deep thoughts. And so if you're familiar with Jack Handey, this will be funny. If not, this will be weird. So. Maybe in order to understand DevSecOps, we have to look at the word itself. Basically, it's made up of these 3 separate words: de, vseco, and ps. What do these words mean? It's a mystery, and that's why so is DevSecOps. So, okay, but that leaves us to like, okay, but what is it? That's a good Jack Handey idea, but, and then why? Like, why are we talking about DevSecOps? Why is this a thing? Why is this important? And I think we could first take a step back and we'll take a quick look at what is DevOps. And you might feel like, oh, this is going to be real special, and I hope it is for you. We can start and look at the cloud, right? We started a decade ago, taking a look at that. And then we have this idea of data, and we liked it really big. And we thought, that's going to be great. And we have this new OSI model, which I really appreciate. Because the old one, it was always hard, right? There's like, which layer? I don't know. So this is much easier. So I really appreciate that part of this. And where are we going really? Like we see that over the years, the last 15 years, we've moved from taking hardware to the cloud and to VMs, and then now kind of moving into the serverless space. We're eliminating the waste that we often deal with, and we're really concentrating on the value. And we're isolating that and building that forward, and we're able to utilize that more. And so why did I start talking about all this? I said, hey, we're going to talk about DevOps, and then I started talking about the cloud and big data and all that stuff. And I think part of it is as we kind of move as progression on that graph is that we saw developers sort of took that, internalized it, and said, yeah, okay, we're going to get ops for free and security, right? Because Amazon or Google or whoever, they're going to manage that. That problem just sort of goes away. And it is true that DevOps grew hand in hand with the cloud. And there was a thought that, okay, DevOps is this inevitable force that's going to happen. Instead of managing tens or hundreds of servers, operations folks now had to manage thousands of servers, and so therefore, like a new model, a new paradigm had to come forth. And this is exactly what Tom Limoncelli says. He says that DevOps is the inevitable result of needing to do efficient operations in a distributed computing and cloud environment. I always like to say that it was this an epistemological breakthrough that you joined separate groups, separate people in these separate silos around a common problem, and they're able to deliver software together. And I felt we also thought about it in another way. We also thought, well, DevOps, we have this inequitable distribution of labor, and the problem sits where we have 10 developers for every 1 operations person. And that was kind of creating this natural silo through the organizational structures that existed. And Damon Edwards, who's one of the original guys who was in on starting DevOps in the beginning and runs the DevOps Cafe podcast, he says, DevOps is not a technological problem, but DevOps is a business problem. And I agree with it. And there's another view as well. You can look at it, if you're coming from like a developer point of view, you could just see DevOps was like another stop along the way from Agile's journey to dominance in the organization and the enterprise. And that's not a far off viewpoint. Even the Practice of Cloud System Administration book, which is a really great book, and I totally recommend it, says DevOps is the application of Agile methodology to system administration. And so, okay, that's fine for DevOps, and now we see like how that came about, but still that leaves us with the question of like, why DevSecOps? And I asked this question myself, and I was worried about this myself, like philosophically, existentially, is this the right approach that we should do? And you start looking at things like Dev, QA, Sec, Data, Gov, Fin, Mar, Ops, right? And we start asking like, where does this end? Can we just leave DevOps good enough alone and just say like, that is, end to end from building to runtime, and all these other things are gonna fit in there, which I think is fair, but I think the key is we start seeing that security needed something different, and whether it's a subset of DevOps or how we think about it, that security finds itself in the same position that operations did whenever DevOps first arose in the very beginning. So we have 100 developers to 10 operations people to 1 security person. So natural siloization across how this is set up in many organizations. And let's see, siloization. I like to make up words, I apologize for that. And security, like ops, struggles to provide value in many organizations. And I see that as a core problem that security faces. Well, let's look at this quote from Steve Belovan. I got a couple quotes from some security authors that I think might be helpful for us and kind of illustrate the point here. But companies are spending a great deal on security, but we read of these massive computer-related attacks, and clearly something is wrong. The root of the problem is twofold. We're protecting the wrong things, and we're hurting productivity in the process. Does that resonate with anybody? Yeah, and that's a particularly damning statement, right? Because it's coming from inside of security, and we're saying like, hey, like the breaches haven't stopped, they've gotten worse, and like people see us as the people that always slow things down and make a big mess of stuff. And that's not a great place to live, and that's not a fun place to live. And it's very similar to where ops was a decade ago, where like the developers like, we're trying to do this agile thing, but like you guys aren't letting us because you want to do like quarterly releases and stuff like that. Another one is this book by Michael Zalewski, and it says, security by risk assessment introduces a dangerous fallacy that structured inadequacy is almost as good as adequacy, and that underfunded security effort plus risk management are about as good as properly funded security work. Does that bother anybody in here? Yeah, it should, right? And we're like, okay, like I want to do engineering, but, and in this book, the first couple chapters is kind of the progress of security over the last few decades, and how we kind of abandoned engineering and in the 90s kind of went to this risk model. And it's not that that's completely wrong, but like we've just sort of said like, I'll accept the risk, do actuarial duties instead of actually building higher quality things. Sometimes I like to show this slide at almost every presentation I give, but I'll often ask the audience, and it's like, does that resonate with you or does that bother you? And it really worries me when no one raises their hands, and I'm like, oh, it's wrong audience. So I'm glad. So we passed that test, and I knew we would right here. Okay, so the SANS 2018 DevSecOps survey says, while engineering teams are busy deploying leading edge technologies, security teams are still focused on fighting yesterday's battles. Does that resonate with us too, right? We feel that. And we see that 95% of security professionals spend their time protecting legacy applications. And this goes to the old axiom of like tech burden can only be transferred. Like you can't really destroy it, it's only transferred. And I feel like that's true with security, where security burden is not created or destroyed, it's merely transferred to other people. And as things get older, like that job sits over with security, and then developers off doing like the newest cutting edge things. A friend of mine does some consulting work, and he goes into places and we'll try to leave everybody nameless in this, but a lot of times he'll work with folks that are doing Kubernetes or serverless or whatever, and he's like, great, how do you get security involved in that? And he's like, we do not tell them. And you're like that's, you know, and they're like big companies, and you're like, okay, that's not a great strategy, but they're always worried that that this sort of, there's this divide that's continuing to happen. And I think that it's helpful for us to look at, like, even the Agile Application Security book says, many security teams work with a worldview where the goal is to inhibit change as much as possible. And we see that across our industry. So new technology, increased organization focused on software delivery, because everybody's talking about the deploy cadence or how often frequently they're able to deliver. I think that's why we need DevSecOps. And so with that, I'd like to look at what is a DevSecOp? What makes someone who is doing DevSecOps, what makes them successful, what's helpful for them? And it's good to realize first, it's not a tool, it's not a CI/CD pipeline that you can put security in. It can't be bought on an expo floor, except probably at this expo floor. I think it's probably fair, right? But it's an inclusive person who's participating in a movement of putting security right in the middle of DevSecOps, which I think is great. I even like the placement of where this kind of landed in the end, right? Security kind of sits there in the middle as a connector. And so hopefully we'll see that as we kind of move through. So the framework that I'd like to talk through that has the seven habits is the measure framework. And so this is new, and I'm just trying it out for the first time, so I'd love feedback if you guys think like measure is helpful or is missing stuff or maybe needs to be tweaked. But the 7 pieces are maker-driven, experimenting, automating, safety-aware, unrestrained sharing, ruggedizing, and empathy first. So let's move first into M for maker-driven. So what do we mean when we talk about maker-driven? It's like people who actually own the idea that like we're software engineers first who specialize in a discipline, security, right? And I think we need to kind of adapt this. Security must be able to write code. And I see people on Twitter kind of debating this sometimes, like, oh, you know, you can do security without writing code. I think those days are past. And I'm actually concerned, like, why is this a hot take in our industry, that like security should be writing code? This is similar to where operations was. It's like, I don't need to do that. I just manage, the Apache config and, copy paste from wiki pages, like a decade ago, right? So, and I think as security people, it's not that you have to be developers first, but be able to like speak the same language as developers, build empathy, and there's a lot of resources available today. I mean, 2 of my favorite development books are easily found here. And so I think that those are good resources, but there's tons, right? Like we know that like you can get access to all this stuff. I also think security has to adopt the maker mindset. We're already using DSLs. We're already doing a lot of development type work, and so even just like config for your WAF or other stuff like this. I like this. Typing dots and slashes until things work, right? That's the prayer that we always hope. But I want to connect that in your mind with you is like security is already doing development work in any capacity, even people that are kind of managing a WAF or whatever it is. Just like operations folks, they were managing their Nginx config or their Apache config and thinking through, okay, now we're going to do config management and Chef and Puppet. We had a lot of these tools kind of arise through that viewpoint. Well, I also like 2 of my friends, Shannon Leitz over at Intuit, Aaron Reinhardt over at United Health Care Group. They both said, hey, the entire security team must learn to code with the subtext of, or you're fired, but they tried not to say that because like that makes people sad. But they sort of said, all right, hey, we're all going to learn Python or whatever it is that you want to learn, but you must do it. And that was on everybody's like performance plans. And these are kind of like large enterprise, companies that you wouldn't expect that. You would expect that at like a a Slack or some sort of like a startup, but not like, not one of these. Okay, so but why is that important? Well, it builds empathy. It provides familiarity with the tools, has security people able to move into the pipeline and kind of experience that. I know even whenever I like picked up serverless for the first time and I started just like trying to configure things, and I had to like open up a bunch of like IAM roles and permissions because I was like, I just got to get this thing to work, right? But that helps build empathy for you as a security person as we're dealing with developers. Like, yeah, I get that. Like when I write code, I also do the same thing because I just want something to work, and then I try to go back and harden it later. Well, another thing that I'd like to put as a premise here is a bug is a bug is a bug, and we see that defect density studies range from 0.5 to 10 per 1,000 lines of code. And the important part is not about those studies which have been done over the last several decades, but that defect density is never zero. And so sometimes we think, oh, my application is just 100 lines of code, 200 lines of code. There's a great example from SNCC. You write 222 lines of code that has 5 direct dependencies, 54 total dependencies, and I think for this crowd, we probably know where this is going. That's like ends up being 460,000 lines of code. And so then we get stuck just like resolving dependencies and kind of dealing with all those problems. The 2019 DevSecOps survey showed that even companies, so the blue is the DevOps elite practices. Even the blue, like they only have 38% lockdown on the dependencies and how they're doing development. So we have a lot of room to grow here. Also, I'd like to put another premise out here: is that you cannot train developers to write secure code. So instead, we need to instead focus on the methods that developers use. Because we don't train developers to write error-free code, and that's the same thing whenever you're doing any other type of development. So you focus on TDD, BDD, ATDD, meaningful comments and commit messages. The developers do teach on like code smells and refactoring, and adding the right instrumentation in places where you can see the telemetry out of your application to let you know what's going on. And this is a quote out of the Agile Application Security book that says, the goal should be to come up with a set of automated tests that probe and check security configurations and runtime system behavior for security features that will execute every time the system is built and every time it is deployed. So we start connecting security in our minds with quality, and that's something that happened in the DevSecOps community survey for 2019. Let's see, it says 1 in 4 people believe that security is synonymous with delivering quality. So that's the piece there. So we're seeing a growth in that standpoint. So what does maker-driven really mean? So if we see security as part of engineering, we view quality as a way to bring security in, and we use code and not vendors to solve our problems. Okay, let's flip over to E. So E is experimenting, and subtext there is and learning, right? So experiments need to be measured, they need to be repeatable, they need to, the great part about doing experiments in your own environment is you get results based on your actual needs. One of my favorite experiments, I spoke with Shannon Leitz over at RSA, and then we also spoke at a DevOps Enterprise Summit on the OWASP versus the real world. So she had plotted out here over at Intuit just what she thought was the blue would be the OWASP top 10 and where they would land, and then broke up the adversaries and tried to track different adversaries through her system and see where they landed. So you have some, like the scanners kind of ended up in the green dots, then red for advanced adversaries on the far left, paid noise over here in the orange. And it's a great talk. I won't try to summarize it all here, but it put a lot of meaning and context and explanation around what's going on their systems at Intuit, and I thought that was really helpful for people to think about. But you end up starting detecting what matters. So start looking at instrumenting all the pieces for account takeover attempts, understanding what areas of my site are under attack, know what likely vector of attacks are happening, looking for abuse and misuse cases. So Zane Lackey over at Signal Sciences, I love this approach. He says, for many years in security, we sort of decided we're just going to cede home field advantage, but I think that we can't do that, right? We actually know our systems, and if we know them and doing that, we're able to have better conclusions out of that. And that's what experimenting necessitates. It actually necessitates that you understand your steady state of your system. So having dashboards or monitoring and instrumentation that you actually know where that lies in the normal world. So some resources, I think looking at Shannon Leitz's stuff, she's DevSecOps on Twitter, and then here's a link to the YouTube, on YouTube for the DevOps Enterprise Summit 2018 talk that I really like. Okay, let's move to A. So the automation of things. When I was at Signal Sciences, I wrote this white paper. In it, and I had this very marketing graph here, which is identify resource misutilization, add telemetry feedback loops, then automate across your pipeline, and then overall influence organization culture. And so on the bottom, it's influence across teams. So as you do more, you grow in your influence, and then as you go higher, you increase your actual effectiveness. These don't have to go in order. There's a feedback loop to it, but I think there's helpful pieces. And we often will look at automate as being our first step. But I find these other two, where you're actually adding real telemetry and able to understand what's going on in our system, that can be more helpful. Again, another Shannon Leitz reference here. She has a secure software pipeline. And in each part of the pipeline, there's questions like, how do I secure my app in design? What component is secure enough in build, in deploy? How do I secure secrets for the app? So I find those as pretty helpful. And we look across our DevOps Enterprise Summit, or our DevOps Enterprise DevSecOps survey. And across the pipeline here, we see the blue is people that are kind of in the elite practice category, and the orange is they have no DevOps practice. We see that there's outperformance. There's still room to grow. A lot of focus on like the build and CI or during the QA piece, but throughout the whole process, like is where we're trying to look. And we're trying to put security testing telemetry in place at those spots. So looking for pre-commit at build, deploy, at runtime, and also in that survey, there was a great piece that showed like even though so again blue is the more DevOps elite. They're actually using more of kind of the standard, what we would consider standard security tooling. So web application firewalls, container application security, open source governance, static analysis, dynamic analysis. So they're actually using more of kind of traditional approaches that we've used, and then they've kind of put it across their pipeline in a lot of different places. So I think that's pretty great. Well, and I think we can focus on looking at continuous delivery and how people deliver software. There's a great book called Continuous Delivery by Jez Humble and David Farley. And one of the things they stress in that book is continuous delivery is about how little you actually deliver at any one time. And whenever I was at Signal Sciences, we really spent a lot of time optimizing for total cycle time. So from time to code commit to actually running in production. And we try to keep that under 5 minutes is what we try to do. And over the last 3.5 or 4 years, we did over 15,000 deploys, and we were really excited about that. Like we were able to push things live, and it took some. Part of that journey was we had to sometimes sit in a room uncomfortably and say, okay, who slowed down the build? How do we make things faster? How do we continue to push this out? How does each developer, as they're pushing this out, like own both the security and the reliability and availability of the system? And so we put a lot of security stuff in the pipeline. So you can do software composition analysis, language linters, like scanning type stuff. There's like Gauntlet or monitoring telemetry, all those types of pieces. But kind of the piece that you want to leave with is thinking, all right, deploys can be treated as standard or routine changes that have been pre-approved by management and that don't require heavyweight change review meetings. So if you find yourself always doing cabs or whatever, like that's maybe not so good. Okay, so a couple of resources on this. I actually have 2 courses that I have on LinkedIn Learning for this. One's on building a secure continuous delivery pipeline, and another one is on DevSecOps automated security testing, so kind of this is more of a development style course. All right, so I see we're kind of running short on time. Let me kind of hustle through the next piece, but I think the next piece, or I kind of went through that last one a little fast, but I want to hit through on this one a little more. So the S, I think this might be really interesting for us as we kind of move over the next 3 to 5 years, thinking about security and safety and how they kind of hook together. So safety for complex systems. I'd like to tell you 2 stories of failure. Okay, you might have noticed I'm a little tall. Right? So one of the problems of being tall is doorways, and they're not a normal problem for regular people, right? But I end up having this situation, and it's those electric locks in the upper left-hand corner, and then those hydraulic assist door openers. And it's not usually a problem. Like on this door, this is a very tall door, so we're all square, right? And so, but I want to zoom in here and I'll tell you about a little story. So I dropped my daughter off at school. This is just last week. And I go in and I'm wearing a baseball hat and I'm just kind of taking her in, and then all of a sudden, boom, like slammed into this electronic lock situation here. And I'm like, oh geez, did I just like have a concussion? Like I hit it pretty hard. And I thought, well, this is this is not good. And so I sort of just, winced, put her in her classroom and then just walked back, and like my pride was a little bit hurt. I'm a little embarrassed I'm even telling you this story here. But why did this happen? And so we can take like 5 whys and do some linear questioning on this. So why did I encounter this problem? Well, okay, we had to have security on the door, right? And why do we have that? Oh, you got to lock doors for safeties. It's a school. Well, okay, why do you need that? Well, society problems, school shootings, stuff like that. It's kind of depressing. Okay, well, even further, but why? We can kind of go another route. Like, why did I experience that? Well, it's a bad design. I actually Googled this, and like some designs have the whole system like mounting above the door, which is really great. Also, it's an old building, so the door frames were automatically lower. And why else did this happen? I was wearing a hat, so it was out of my peripheral vision, and I woke up late, and I was like, you just put on a hat and take the kid to school. And why did that happen? Well, I went to bed late, and then why did I do that? I was living life in a hurry, so and I was less thoughtful, and you could just kind of go down this path. And 5 whys is good for linear and simple systems, but whenever you start dealing with complex systems, which what I just described is not really a complex system. Now, it does have, like, a human is a complex system, kind of society is a complex system. Anyway, so those are the pieces as we kind of think about this. And I'd like to say, like, we abstract complexity, and that's kind of how we are able to rationalize as we move about through life, right? Human beings, we kind of just abstract that to as a person. We don't think about all the complexity that's involved inside of that. Society, psychological, we just have like too much cognitive load, like we can't deal with everything all at the same time. And so software deals with this same thing through abstraction. Earlier we talked about those 222 lines of code. I write those lines, and then we're good, right? Well, that's a layer of abstraction. Like, I'm dealing with the frameworks and pieces there. So I'd like to instill this idea in you, is that root cause is a myth. It lacks full picture. This is whenever you kind of drive to root cause, this instills kind of a blame-like culture. It forgets any organizational decisions that led up to it, any of the prior legal and other type of ramifications that went into it. And in his book, Drift into Failure, I'd like to read this quote, because I find this book to be super helpful. So, drifting into failure is a gradual, incremental decline into disaster driven by environmental pressure, unruly technology, and social processes that normalize growing risk. So no organization is exempt from drifting into failure. And we can look at another example that's maybe more interesting to us, right? If we look at the Boeing stuff. So they have the MCAS system, which was, if you build a bigger plane, keeps the plane from stalling. And it is essentially automation software. And in certain situations, the MCAS commands the trim in this condition. In certain situations, it'll take over the trim without notifying the pilots. And J. Paul Reed has a great coverage on this. And he says these events unfold in minutes, and the system they were operating was pretty much like every 737 they've been likely to operate in their careers ever. And the news, let's see, wait, take back. So, and this is in a context of them being told that the system, oh geez. There it is, okay. In a context of being told that the system that they were operating was pretty much like anything they've ever used before. Maybe I skipped the first part. Sorry, slides are, okay. So the new safety automation, the other thing he says in his article that I think is pretty helpful is the new safety automation is capable of overriding operator input in silence and in ways that were poorly documented by designers, unclear to operators, and promised by developers. That nobody had to get training. On. So that was a big key, right? And that was a selling point of the whole system. That this safety automation now proved to be the system to become critically unrecoverable, and at least in one case was the cause or a contributing factor to the crash there. So does high-speed decisions about systems sound familiar to any of us? Right? Like this is important to us. In his article, J. Paul Reed says this is why software developers really should pay attention to this, because this is like Boeing's like, hey, we're going to fix it, like we're going to release a software patch to the system. And the growth of complexity in society has gotten ahead of our understanding of how complex systems work and fail. In his book, Sidney Dekker says this. And this is I just pulled this randomly off of the internet, but this is a chart of how like serverless systems are hooked together, right? Like, is this easy to keep in our heads as we're like operating at high speed, right? No. And my friend Matt Stein says this, and I think this is very true. It's like we have made a huge error here. But it puts the onus on security and operations to rationalize system models. And Adrian Cockcroft says failures are a systems problem because there's not enough safety margin, and so we're seeing more safety type discussion happen in the world right now. And we see failure as an inevitable byproduct of complex systems' normal functioning. So where does security fit in? I think that we can add a safety margin. We add telemetry and instrumentation. We start participating in blameless retrospectives. I think that's really helpful. So instead of trying to be the finger pointing, we start kind of trying to go blameless. And honestly, I think there's more to explore in this area. I think the overlaps between safety and security, kind of in his book, Sidney Dekker sort of bifurcates the two, but I think that there's some overlap that we can take a look at. So some of these books and videos have been really helpful. This YouTube series, Understanding Human Error, has been pretty instructive for me, so I'd recommend it. All right, let's go to the U. So unrestrained sharing. So when we talk about this, like often culture is one of those key aspects of DevOps. And in the beginning part of DevOps, we all said, DevOps has no definition, it's culture. And so eventually we kind of grew out of that and said, we'll give it some more structure. But the CAMS model, so like culture is the first piece in the CAMS model. And I think that fits for security as well. A lot of times we don't share kind of what we have inside of our organization with the other organizations. So here's a good quote from Patrick Dubois, the guy who coined the term DevOps. He says, culture is the most important aspect to DevOps succeeding in the enterprise. And I think DevSecOps is the extension of the DevOps culture for the inclusion of security. That's what we said at the very beginning, right? Rich Smith over at Etsy, he said, a security team who embraces openness about what it does and why spreads understanding. And we know this. Oh yeah, okay, good, it comes up good there. Sharing affects culture. Right? Like that's just because you let one team know, hey, this is what we care about, other teams start participating in that. So unrestrained sharing goes against what we see as our normal operating procedure, and sometimes it might feel uncomfortable, but it does break down silos, and we see that as a key piece here. And I always kind of say these are the 4 keys that I view as culture. So having a mutual understanding, being able to share in the language, having shared views, and then being able to put tooling and collaborative tooling in place for that, I think is helpful. And why is this important? So rank the top challenges of your application security processes, okay? They're almost the same. I mean, there's a little bit of variance between the two, but I mean, it's not that big. But on the far left, number 1 problem the developers say about security. We find out about problems too late in the process. And then in the middle, one over, is the next one is slows down development. Okay, I think we already knew that, but the last one says it's not clear of what's expected of us. So there's a gap here. There's a gap here. So we need to make invisible as visible, adding security visibility. And I'm going to try to hustle through the last few slides here. So security observability gives us more of what's happening below the surface. And Jason Chan over at Netflix, he talks about doing a paved road approach, treating security as normal, making security as free if you're using the system. And I think we can't leave the auditors out of this. I'm working on a project called Dear Auditor. Go to dearauditor.org. It's a love letter from DevOps to auditors saying like we promise to bring you along for the journey. I'd be happy to, like, it's in GitHub, we accept pull requests and stuff, but be happy to have you take a look at that, dearauditor.org. So. Other resources that I'd give you for this is check out the Phoenix Project, Agile Application Security, and that Dear Auditor site that I mentioned. Okay, let's talk about ruggedization. I'm going to try to fly through these. So, ruggedization, where we're living with our system right now. So I feel like we focused on when we were thinking about rugged software, especially in the beginning, we were thinking about software bill of materials, so you know what you have everywhere. And then we started thinking like, okay, with this we also need to favor short-lived systems, have cattle, not pets. I really like how and operations has been on board with this for a while, so I think this is good. But Sunil Yu, he has the DIE framework, which is distributed, immutable, and ephemeral. He's working on some papers to kind of prove out that like just if you have these 3 characteristics.
Take your time. There's no rush. We'll adjust the schedule. So please take your time.
Okay. Yeah. So we have these like this. We have these three pieces here where we look at, okay, if you have distributed systems, immutable and ephemeral, like you actually end up with a more secure state in the end. So I'd recommend taking a look at his stuff. So where do I think ruggedization is going? Or like if we actually have to be more rugged, how does that look? I think there's 2 key aspects over the next year, 2 years. I think it's in deception, and I believe it's in chaos engineering. So deception, this is stuff like deploying honeypots, tar pits, man traps, camouflage. It's easy for us to get started at the app layer. Like we can just inject certain HTTP headers. We see those. We can put them off in other systems. My friend Philip Maddox does the honeypie project. You can also check out Deception Logic. That's some really great options for being able to get started with this in your infrastructure. But I like to, whenever I meet practitioners that are doing deception, like there's some pretty cool stuff that people are doing. And a lot of them won't talk about it like as openly. So hopefully we'll get more open discussion about it. And so that would be really helpful. I have some links to some good talks that I think that might be helpful if you're interested in the deception space. Also, Adrian Cockcroft says, we're moving from disaster recovery to chaos engineering to resiliency. He sees this as kind of the path of like how engineering is moving in the world right now. And so this is empirical rather than formal. We don't use models to understand what the system should do. We run experiments to learn what it does. Michael Nygaard says this in his 2nd edition. You have to get the 2nd edition for it, but it's Release It, and it's a really great book. He's got a lot of other design patterns, but he has a great chapter on chaos engineering, which I think is helpful. So these are experiments that span from engineering to security. Often they're manual opt-out, but depending on your organization and your tolerance for risk and all that sort of stuff, you might want to make them opt-in. But they provide valuable learning. So Aaron Reinhardt did Chaos Slinger. They did CHAP over at Netflix, Chaos Monkey as well. And so here's a couple like links for you if you're interested in this. There's Aaron Reinhardt's talk. There's Release It, the book from Nygaard, Philip Maddox's talk, and then Herb Todd, I can't say where he works, but he did a talk over at LastCon, and I love that talk. So I would totally recommend checking that out. I guess that was a year ago. So yeah. Okay, let's close this down, and we'll talk about empathy. So I think empathy is the last kind of key here. And having empathy-based teams is an approach that we can take when we're kind of doing DevSecOps. Well, let's go back to the well. When I think of all the arguments the CISO and I have had, I realize how silly most of them were. And it makes me wonder why he wanted to argue over such stupid things. I think I'll go ask him. Okay. And who hasn't found themselves at some point in their career saying those stupid developers, right? Or you've had a friend say that, right? And then I've had developers tell me, it's like, you security people, like you guys just want machines powered off, unplugged, and like, but both kind of assume that the other person is like ignorant, right? If you catch kind of the drift on that. And another poll from the survey, from the DevSecOps survey, is that developers continue to believe that security is important, but they don't have a lot of time to spend on it. So they've continually said 50%, 48%, 48%. It's like, I love it, I love security, don't have time to work on it. And in the end, we start saying, okay, let's not be a blocker, let's be an enabler, let's like help the business move forward. And so that's kind of closing it up here, but I'll close up like this is the framework that I think that could be helpful. I would love any feedback on this, and if you're like, oh yeah, you missed something, or different bullet points or whatever, like that'd be helpful. Also, if you're interested in the book and you want to share your story of how you've done DevSecOps transformations, or had successes or failures or anything, you can email book@devsecops.org, and somebody from our core author team will get in touch with you, and we'll interview you, and we'll get some quotes and stuff like that put in there. And we'd love to have your story included. All right, and that's the slides are there, and I think that's it. So I appreciate it, and hope you've learned and are optimistic. I'm really optimistic about DevSecOps. I really think it is a great growth place for us. So hopefully encourage you all. So appreciate it. Okay, so you just read the question out? Yeah. Yep. Okay, don't you think security developers are a different breed than security administration? Not all security people need to code. Some need to coffee and help devs. I think I get that viewpoint. I just think that, and you know, I could be wrong, right? But operations have dealt with the same thing, right? It's like, well, operations people don't need to code. They just write some scripts and whatever. But I think kind of understanding that the stuff that the way that I'm able to kind of empathize with security, that is helpful. So I don't know. I mean, I guess there's an option for security administration, but even operations folks, like if you're not writing code, I find that to be something that like I always recommend people to do. I think that it's a safe thing to learn how to write code because you will have security in your job in the future. So I don't know if that's helpful or not. I'm happy to debate that with somebody if they want. But all right, I guess that's it. Thanks, y'all.